So although we will not touch anything about programming, but we still need to understand the technologies behind the VR because yeah, I will say that the limitations of the VR is not by the software development or developer. So mainly it's about the hardware. So if you have the sensor, if you can sense the motions, if you can do the output, etc. So somehow the software developer so they can handle it. But without, for example, you say that hey, I want to PT, right? I want to sense the joint of the upper limb. But if we do not have the hardware, if we do not have the input sensor, so even if you go to the software developer, they do not have any method to handle this kind of thing. So the most important thing is you understand what is the sensor, what is the technologies behind the VR, so that you can select what kind of VR that we need to use or we can use. And the most important things about the VR, of course, is about the motion sensing, okay? Because you want to capture your human, okay, your subject movement, and then all the subject movement can be put it back into the VR system, and then to display all the things. So I would say that the motion capture, or I would say the motion sensing can be divided into two different types. So one is optical. Another thing is electromagnetical. So let me talk about the motion sensing first, and then let me talk about what is the motion capture for the electromagnetical sensor. Electromagnetical sensor is easy to understand because all of us, we already have an electromagnetical sensor in our smartphone. So in our smartphone, there are two types of electromagnetical sensor. So one is called gyroscope, and other is called accelerometer. This one, gyroscope here is, for example, if you are, I would say that if you are using some mobile phone that is around 10 years ago, most of them they have the gyroscope inside. Gyroscope is something like this one. So they have the sensor to scan the X, Y, Z axis. So when you are rotating your smartphone, so somehow they know your XYZ axis is rotating. So it's called gyroscope. This one gyroscope. And then the gyroscope lets you know that your mobile phone is you're using your mobile phone vertically or horizontally, etc., etc. But around 10 years ago, so most of the mobile phone changed from gyroscope to accelerometer, this one. So accelerometer, they are only sensitive to the gravity, okay? So they know where is the gravity. They know where is the gravity force here, the G. So somehow they can still perform the, I would say that they can still perform the orientation. They know the orientation of your mobile phone, vertical, horizontal, etc., etc. Yeah, that is the question. So see that? So we have the gyroscope, we have the accelerometer. Gyroscope is sensitive for the XYZ diagonal axis, and then the accelerometer is only sensitive to the gravity. So which one is more sensitive? The answer is gyroscope. Honestly, if you say that about the sensitive or about how you can get the accuracy of the data, gyroscope is better. But because gyroscope, they have the free axis sensing. So somehow, if you say that the robustness of the gyroscope, they are not as good as the accelerometer. That means if you are using the mobile phone around 10 years ago, so when you use the mobile phone for 1 or 2 years, your gyroscope here will be broken. Yeah, that is one of the component in your mobile phone that will be easily broken. So when you broken and then you cannot sense the orientation, you cannot sense the motions of your mobile phone. So later on, because consider about the robustness, consider about I want to use the mobile phone for a longer and longer time. So loss of the smartphone, they changed from the gyroscope to accelerometer. So accelerometer, yeah, because they only have one access for their sensing, so somehow is more robust and then it can last for longer. But if you can't saying that the sensitivity is not as good as the gyroscope. And one more advantage about the accelerometer here is because it's smaller. Gyroscope is bigger, accelerometer is smaller, and then for this kind of smaller mobile small component in your mobile device, so that your iPhone 17 it can be thinner, and thinner. So that is the situation. So both of them, they are using the I would say the electromagnetic field to do the sensing. So somehow this one, the pulse is cheaper. Okay, consider about the price is reasonable. So if you go to Taobao or go to other Chinese market to buy the accelerometer or the gyroscope, this kind of electromagnetic field motion sensing. So I remember it's around $10. Yeah, it's really cheap for you to buy one sensor. And then you can also put this kind of sensor into a single humanoid device, just like this one. Okay, it's a skeleton. So when you wear this kind of device, there are lots of accelerometer, gyroscope inside this one. So you can sense the scan. You can sense the joint of each of your parts of your body. So this is better. And then because they are using the electromagnetic field, so somehow it can work under the sunshine. So even if you are in the outdoor condition, so still they can work very, very good. So both accelerometer here and then gyroscope, they can work in outdoor and indoor, and it's cheap. So that is the advantage. Disadvantage is, of course, they are not so sensitive, and then compared with optical device, it's not so sensitive, and then it's a little bit bulky, right? So if you wear this kind of device, it's a little bit bulky. So that is the problem. And one more disadvantage. So yeah, here this one, you need a lot of the effort to do the calibrations. So before use, so you need to do lots of the calibrations to make sure that all the joints they are in a good condition. Otherwise, data that you have captured cannot be fully applied to your research. So compare with the electromagnetic field, so we have another method to capture the motion sensing, motion capture. It's called optical. Okay, optical. Previous one is electromagnetic, now is optical. For the optical motion sensing, so they are using some infrared camera to sense your body. So on your smartphone or your iPhone, etc., so most of the camera here is RGB sensor, RGB. So that means that they only understand the color of your resultant image. But for the infrared sensor, this one, for the infrared sensor, so they will understand the depth, the distance between your camera and also your object. So they know the distance of your camera. They know the distance between the camera and your object. So most likely the gear, this one, here they are using the RGB camera, but for your front camera, this one. So most of them they are using the infrared, because the front camera is used to unlock your mobile phone. So if you are using the RGB, so it's easy to get your photo from IG, Facebook, or I don't know what is the social media that you're using. So you get a photo and then you can unlock your phone. It's not so secure. But if you are using the infrared camera, so somehow they know the depth of your of your face. So somehow they know the facial information. So it will be more secure. So your front camera will be infrared, and then they know the face structure of your face. So that's the situation. So remember, I'm sorry, is yeah, is invert. So try to remember one of the brand. OptiTrack, this one, OptiTrack. So most of your research or most of our equipment in our lab, so most likely for the infrared camera, they are using the OptiTrack, this one, OptiTrack. So the OptiTrack camera, the infrared camera, so most likely they will track the I'll say that they will track the 3D structure of your body. So they are sensitive about all spatial marker. So OptiTrack infrared camera, so we want to understand the distance between some of the, we call it here, marker, this one, the white ball here, white ball. We want to understand the distance between the camera and this white ball, the sensor. So similar to lots of the Hollywood movie, when you have watched the Hollywood movie, so most of the actions, so they are captured by the motion capture system. So the actor that perform the motion, so they will wear some suit, and then on the suit they will have some special marker, this one, the white ball on their body. So most likely, so there is a one, exactly about 30 something, 30 marker on their body. So the marker will be located on the joint of your upper limb, of your leg, of your head, of your backbone, etc. So all their closures, all their faces, all this kind of information, RGB color informations will be negated. They will forget all this kind of information. They only know the distance between the camera and the white marker. So the image that they have captured will be similar to this one. So they only know the point, the marker on the 3D space, on the physical space. Then we have the algorithm to join all this kind of marker together, because XV guy, we are humanoid, we are a human body. So for example, our joint, we have the constraint here. You cannot rotate your joint. I would say that this part, you can rotate your joint more than 180 degrees, right? So we have the constraint of all our body movement. And most likely when we can locate the head, so somehow it's easy to locate all the other parts of your joint on your body. So they will map into a skeleton data, and then a skeleton data will match to a 3D model. And then this 3D model will match to other 3D model. So somehow they will transfer all of your motions from the marker data, from the point data, one to one to one. Finally, you have the 3D model. So for the optical motion capture, and the most important thing is, yeah, of course, is the accuracy. Compared with the electromagnetic field, so the accuracy of the motion capture sensor is incredible. So as I mentioned before, so if we are using motion capture sensor in the case system, so the accuracy will be 0.25 mm, 0.25 mm. That means all the details, facial expressions can be captured, and then all the special movement can be captured. This kind of effect, so most likely you cannot repeat or you cannot teach by a artist, because yeah, our human, when you're moving your hand here, when you are moving your arm, so another part of your body, they have a small movement. So why we want to do this kind of capture this kind of actions, because this kind of actions you cannot simply use a algorithm to capture all the things. When you're moving your left hand, your right hand will be moved a little bit, a little bit, a little bit. So you try to balance yourself. And this kind of balance, this kind of data is really important for the PT. I guess to be the PT. OT, maybe you care lots of things about the hand or lots of things about the facial expression. But for the PT, most likely is the movement of the big joint. So this kind of more balance or this kind of gaze, so it's not easy to calculate by the algorithm. So what we are going to do is using the motion capture, and then yeah, we use this brand of the motion capture OptiTrack, and the accuracy is 0.25 mm. That is the I would say that advantage of using the motion capture system. Disadvantage that we have mentioned before, yes, it's really expensive. So one camera, so it takes around, exactly remember, it should be 5,000 to 8,000, something like that. And then you cannot use one camera to do all the capture. So most likely you have at least 4 or more. So this kind of camera will spend you about 30 something, 30 something to 40 something. Or if you have more camera, for example, you have different angle to trace the infrared. So you need more camera. And then it takes 100,000. So most likely a one motion capture system when you have multiple camera and then you have the supercomputer to calculate the motion, and then you have lots of the central control, central management software to manage all the things. So most likely it will be around 200,000 Hong Kong dollars. It's quite expensive, and that is the problem. So most likely it will be used in lab settings or yeah, most likely it will be lab setting because it's really expensive. I guess you will not spend 200,000 at your home to capture your motion. And yeah, lab settings, hospital, university, so they will buy this kind of sensor. It's more accurate, especially when you are doing the research. You do not want to pre-process your data. So you want some sensor that is perfect, and then you can get the data that you can use. So the disadvantage is first, it's about the money. Second, so because they are using the infrared, so it cannot be used under the sunshine. That means it cannot be used under the that means it cannot be used outdoor. It can only be used in indoor settings. So if you go to some of our lab and then some of our motion capture room, so somehow they have the blankets and then they will try to block all the sunshine, and that is that is one of their limitations. So we have quite a university, right? So we have lots of different labs, and then we have quite a number of this kind of optical motion capture settings. So even in our department, so we have patient science department. So we have, except remember, two motion capture system. At least we have two. No, we have three. Yeah, we have three. And then in Department of Computing, we have two. So we have different scale of motion capture system, and then for different purpose. So most of them, they are fine-tuned for the special purpose. For example, if you have go to the gates lab, right? So motion gate gate lab. So somehow they have a special motion capture sensor using the optic chat and then fine tune to find the upper limb or lower limb motions. So to check whether your subject they have the perfect balance of their body or not. And then the biggest one should be in School of Design, as I remember, because they want to do some motion capture for the animations and then for their video production. So we can still use it. So if you want to try and then wear the full gear of the motion capture suit with the marker, and you can let me know. So you can see that the motion capture here. So there are lots of so many motion capture sensor, and then they capture the your motion in different directions, and then combine multiple image together. Only will have your yeah motions information, and then we know what's going on with your motions. So we will capture all the things by the motion capture sensor, and then we'll find the actor to do in this kind of three-dimensional settings. So this one, exactly remember, it should be half size of a basketball match, so something like that. So it's big enough for you to do different motions, and then yeah, most likely they will do the kung fu, yeah, kung fu motion capture. They will also do the besides kung fu sport, basketball, or this kind different kinds of special movement inside this studio, motion capture studio. So it is in the ground floor of School of Design building, yeah, we core. So yeah, it's nice if you have chance. So we will go here and then yeah, we can do a versus if you want. So the software that you capture the motion data, so the hardware here, just like we have mentioned, the infrared camera is called OptiTrack. So nearly all the motion capture equipment in our university, most of them they are using the OptiTrack. And then software will be the motive. So here. So before you do the motion capture, most likely we need to do the calibration. So we have a special sensor here. And then we will travel inside the 3D physical space and then clear all the data, just like this one, we funny, clear all the data. And then we will start to do the capture inside the motive. So inside the motive, they will ask you, hey, before you capture the motion, you need to do the calibration, and then we do the calibration. So that is the settings. And then after that, so we'll put a special shoot on your body. And can you see that there are lots of special marker? All these kind of special marker will be inside the motif, will turn and then capture inside the motif, and then we'll turn into the motion data, just like this one. So most likely, so we have the 37th marker on your body, cover most of the joint on your body. So yeah, it will be good because they will try to understand all the joint, all your scatter motion. Some of the PT, they will, yeah, when you're using the motion capture, I'll say that hardware and software, so perhaps you need a technician to do it, because when you put the marker, so it will be I will say that a special technique. So if you put the marker in a wrong place, or it's not in a perfect place, so somehow all your research data, they really care about the accuracy, right? So if you put, for example, on your need, you put somewhere else that is not the perfect place, and then it will affect I would say that it will affect the research data that you have collected. So yeah, this is another technique that you have to learn, because no one loves the data pre-processing. So once you have put all the marker on your body, you can start to capture, and then finish, you can stop. And if your data is perfect, and then if you do not have any data cleansing or data remapping, so all the data is captured here, and then you will have the time t equals to 0 to t equals to the end time, and all the motions will be captured. So when you put into Blender or other software to do the recognize, so you will set the orientation, you will set the central point to the 000 here, just like here, and then compare all your subject, whether their movement is good or not. And that is how you analyze the motion data in PT or in OT. And then you ask, hey, Peter, so where is the accelerometer, gyroscope, or the optical motion sensor in a home device? Of course, in your home device, so you cannot find so many expensive optical motion sensor. You will also cannot find the special suit of your gyroscope, etc. But both of them are ready inside your home use device, but they are not lab settings. They are not for the research setting, because compared with the price, it's only few thousands. And then if you compare with the full gear of the motion capture sensor in your lab, so it will be 200,000 to some of them goes to 1 million dollars. So you cannot compare with them. But still, there are sensors inside. For the optical motion sensor, so they are here. Okay, so sometimes we call it um, um, base station, sometimes we call it lighthouse. So whatever, here this one is the optical motion sensor, or we say that they are the infrared camera. This one is the infrared camera. So they sense the marker on your head-mount display, and then on your hand, on your handheld device. So they try to estimate the distance between your camera and also your head-mount display, and also your handheld device, so that they know whether you are a step moving forward to the camera, or a step moving backward to the camera. So they know this kind of situations. And for the accelerometer and then gyroscope, so they are inside the handheld device, and then they are inside your head-mount display. So just like your camera, just like your smartphone, so they have the accelerometer and then gyroscope inside. So they are ready here, and then of course it's not perfect, but still compared with the price, so they are reasonable. For the optical motion capture, so if you are buying 10,000 versions, so exactly remember they have 2 or 4 in the settings. And then for the accelerometer and also gyroscope, they have 30 something on their handheld device and also head-mount display to capture all the information and then transfer the information to a scattered data to the motion data. So if you are using the home use device, so somehow you can capture their hand, and then they can capture your head movement inside the VR system, inside the VR settings. And then some of your classmates, so hey Peter, I'm the heavy user, and then I pay PlayStation a lot. So in the PlayStation VR first version, I can still find the camera here. But in the PlayStation 2, so I cannot find the camera. So what's going on? Both of them, they are 6 DOF, right? They are 6 DOF. So if you say that gyroscope and accelerometer, such kind of electromagnetic field motion sensing, they can only scan the orientation. They cannot sense the position of our head and our hand. So how come the new PSVR2, they do not have the infrared camera, they do not have the external camera, they can still get the positions of my head and hand. So what's going on inside here? The reason that, yeah, because the algorithm improved, some of the programmer, developer, they are doing really hard. So they want to cut the cost of the VR device. So when you are playing the VR around Kinesco, so this kind of the VR device, they use the external camera, infrared camera, yeah, external camera to find out your position, okay, of your body and your hand, etc., etc. So you need to install the external camera in your lab settings or at your home, so they know your position. So yeah, it makes sense, right? But install the additional camera, it takes time. And then lots of the people find, hey, it's really troublesome. Can I just cut the external camera, and then can I cut all this kind of infrared camera, because all of them are really expensive. So can I do that? Because at this time, the VR device is 10,000 something, but now the VR device is around, yeah, the cheapest one should be 2,000 something to 3,000 something. So a lot of the developer, they spend the effort, and then they develop a algorithm from the outside in approach to the inside out approach. So inside out is not the Pixar movie. So inside out means that you carry the camera on your head-mounted display. And then if you have the experience to play with the VR device, so they ask you to sense or to walk around, and then find out the safe area to play the VR, right? So yeah, it's also correct. The VR system want to find out the best location that you can freely move within this 3D physical world. But another reason is when you are when you are wearing this kind of the HAMA display, so they turn on your camera, and then they scan your camera information. They scan your environment information. So they capture the environment information by using a very low resolution camera. It's only a black and white camera to sense about your environment 3D information. So this kind of technique is called interior measure unit IMU method. So they capture all your, for example, they know that this one is a sofa, and then this one is a bookshelf, etc., etc. So they know that you are moving around your environment, and then use your environment information to estimate your positions of your head, hand, and also your body. So yeah, they cut the cost. So they cut the cost, and then yeah, they have a more convenient settings when you are playing VR. Now you need not to carry, and you need not to install any camera. You just carry the camera on your head, and then all the things can be done. So we call it one-stop solutions for all the VR device. Yeah, that's perfect. And then yeah, it's a enhancement of all the VR device. But honestly, compare with the accuracy, external camera is always the best. External camera is always provide you a better accuracy for your experiment setting. So if you are saying that you want to do the research data and then you want to capture the more accuracy data, so this one outside it is always perfect for your research. So we always say that we don't want to do any data cleansing. We don't want to do any data pre-processing. When you go to research, we want, hey, once I have captured the data, I can analyze. I can have a look PT, right? I can have a look with the data immediately, and then I can do the research immediately, identify this one is correct, this one is incorrect, etc., etc. So use outside in. This one is perfect, better for your research. If you are not concerned about the money, if you are not concerning about the, I would say that concerned about the installation, laboratory testing, this one is always the best. And then you will always ask, hey Peter, you have yeah, we have to do the application, right, for the motion sensing. So why I need to use the gyroscope, or why I need to use the motion capture sensing or infrared camera? So even my webcam, yeah, here can do it, right? So we have tried the Google Teachable Machine, and then Google Teachable Machine can really help me to capture the image of myself and then capture the image of the body. The answer is correct. The answer is correct. So if you are not asking for a really details data, so always you can always use the webcam. But always remember that the motion capture infrared camera, the accuracy is 0.25 mm, 0.25 mm. But for this kind of the motion capture system, so the angle, okay, the angle that you can capture. So I would say that the error is around 25 degree, 25 degree. So most likely they can capture here, 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 okay? So it's I would say that they cannot provide lots of the difference. So you cannot measure 10 degree because the accuracy or the error for the camera to capture is around 20 degrees. So they cannot find out the really big difference between this angle and this angle, 20 degrees, right? So if you are always asking for a research purpose, so if you have the money, if you have the research lab, so always use the infrared camera. For the webcam or all sort of things, it's not perfect to do it. But if you say that, hey, do not have enough money, and then I want the user, they can use their smartphone, they can use their home use device, smart mirror to do all sorts of the actions, then just do it. But if you are asking for prepare the research paper, don't do it. Okay. And then yeah, back to here. All this kind without a marker, without the marker, without the, I would say that without the gyroscope, etc. We call it motionless or markerless. Sorry, markerless, not motionless. Markerless sensors. They are long contact markerless sensors. So right now we put lots of the effort to use the camera to sense our body. So right now we cannot do lots of the motion sensing, but for the hand, for our body, and some of the facial expression, we have the ability to do it. So there are two different approach. One is using a webcam, RGB data to do it. So there are lots of good algorithm, screenlet, and also lots of the algorithm to do this kind of the motion sensing. Or for a better way, so still there are some home use device for you to capture the infrared information, depth information, depth data. So there are two, for example, Microsoft Azure Kinect. So this one Kinect, they help you to do the motion sensing. This one. So at the same time, they can sense around 6 data, 6 human at the same time. And then if you want to do the hand motion sensing, so this one OptiTrack. Sorry, this one. Um, this one. Sorry. Here, lip motion, lip motions. So here, lip motions. So they can help you to stand the motions of your hand movement. So for the OT, I guess the Leap Motion can help you a lot. For the PT, Kinect can help you a lot. So both hardware can help you to do lots of the sensing and then to do some interesting application. For example, you want to encourage your subject to do the motion sensing or your subject to do the exercise. So both of the hardware can do it. And of course, you can use your webcam only. Still, there are lots of the algorithm to do this kind of technique. But for the hardware, this is two hardware that I recommend you to try.